to be produced of each type so as to maximize the profit. This is a maximization problem. Okay, what you will do first, you note roughly the entire problem. How? Say, two types of hats. Suppose this is H1 type, one type of hat, and another is H2 type of hat. Okay. Now, profit per unit, first two types of hat, H1 and H2. Time required, time required, time required two times from two times the requirement of time for hat 2. Okay, just I say I'm taking the time required for type 2 of hat is 1 hour. Then twice of this time required for hat 1. But the available time, in this case, available hours is 500. How? Because if you produce only the type 2 hat, then you can produce 500 hats per day. Now I am taking, say, 1 hour is required for hat 2. That's why the total available hour is 500. In this way, we will first note the problem. Then what is the demand? Demand is limited. Demand is limited, and it is given per day. The demand is 150 hats for each one type of hat. And for this type of hat, what is the demand per day? That is 250 units. That means you cannot produce more than 250 units or number of hats per day for type 2. Okay. Now, profit is given. Profit, if you sell the hat in the market, profit per unit for this type of hat is rupees. This is rupees 8. And for this type of hat, the profit per unit is rupees 5. Okay. This is the production problem. Production planning problem. Okay. Now, how we'll follow it? What you have to determine from this problem, you have to determine how many you will produce of hat 1 and hat 2 so that the profit will be maximum. Suppose you will produce x1 units of hat 1 and x2 units of x2. Suppose you have to determine this x1 and x2 so that the profit will be maximum. Okay. So for time constraint, what will be the limitation for time? If you produce 1 unit, then 2 hours will be required. Now you are assuming that you will produce x1 units. That's why the total time will require 2 x1. And for this hat, 1 hour is required to produce 1 unit, and you are producing x2 units. That's why 1 into x2 is the total hours required to produce x2 units. You are assuming that you will produce x1 units of hat 1 and x2 units of hat 2, and that must be less than is equal to 500, because this is the limitation of the hours per day. Now, for demand, what will be the constraint for demand? The maximum demand per day for this hat is 150. That's why x1, we are producing x1 must be less than is equal to 150. Okay. And for this type of hat, the maximum demand per unit is 250. That's why x2 must be less than is equal to 250. This is thought. Okay. And the number of units of production cannot be negative. it may be either 0 or positive. That's why x1 greater than or equal to 0 and x2 also in similar way must be greater than or equal to 0. That is called non-negativity constraint. So this is the constraint. That's why it will be subject to. And what is the objective function? Objective function will be objective function will be maximize z is equal to maximize z is equal to 8 rupees profit per unit for this hat, and you are producing x1 units. That's why the profit will be 8x1. Per unit profit is rupees 8. We are producing x1 units of hat. That's why the profit for type h1 hat is x8 into x1. And for this hat, per unit profit is rupees 5. And you are producing how much? x2. That's why the profit will be 5 into x2. And this will be the profit function. It will be this. The linear programming problem will be this. This is the formulation of the linear problem. The problem is maximize z is subject to these are the constraint. Thank you. In this way, you can formulate a linear programming problem. This is the problem which is taken from the study materials SLM, study learning materials on Netaji Suভাষ Open University MBA course. Okay, the formulation part is one. Later I will show how you can solve it graphically. That I will show later. The formulation part is one. Okay. If you have any question, then please note to the comment box. Then definitely I will reply it.